Hello and welcome to another video lesson in General Mathematics. This time we are going to tackle evaluating functions. And the rule when evaluating functions is that we have to replace and simplify. Replace every x in the function rule f of x with a given replacement value. Then, simplify the resulting numerical expression. Example number 1. We want to evaluate f of x, which is equal to x squared minus 4x plus 1 at the value of x is equal to -2. So we'll have to replace all the x's in the function with the value -2. As you can see here, so -2 raised to 2 is -2 times -2, that is 4, while the product of -4 and -2 is +8. And then we will add 1. So the sum of 4, 8, and 1 is 13. Therefore, the value of our function at x is equal to -2 is 13. For our second example, we have a rational expression or a rational function. We have to evaluate f of x equals 2x over x minus 2 at x is equal to 4. So our replacement value is 4. Now we will replace all the x's in the function with the value 4. So we'll have 2 times 4 all over 4 minus 2. So our numerator will be 8, while our denominator is 2. And 8 divided by 2 is equal to 4. Therefore, f of 4 is equal to 4. This time, let's understand the language of piecewise functions. So, whenever you see a function that is expressed this way, this is a function that is piecewise. We call it piecewise because its graph is like a combination of pieces of graphs of different functions. So this is a language that you have to understand. Now, it's important that you take note that when our function is piecewise, our number line is divided into intervals. And then, piecewise function presents different conditions. Like in our example, the conditions are when your x or your input is a number that is less than 0, meaning negative, what we will do to the value is that it has to be increased by 1. So when you input a number that is less than 0, you have to add 1 to it in order to obtain the output. For example, when I input the number -10 to the function, what I will get is -9, because again, the number -10 is inside the interval x is less than 0, hence I have to use this function rule, which says the number should be increased by 1. So if I will input -5, which is again a number that is less than 0, the output will be -5 plus 1, which is equal to 4. So if I will input -1, again this is less than 0, so what we will do is we will add 1. And the sum of -1 and 1 is 0. Going back to our piecewise function, it also says that if the number, if our input is between 0, including 0, so the symbol, this symbol indicates that the number 0 is included in the set. So from 0 to 5, but 5 is not included. So if we will input a number that is between or inside this interval, the output will be automatically 10. Like when I input 0 to the function, what I will get as an output is an automatic 10. If I'll input 2, 2 is within the interval 0 to 5, so the output will be an automatic 10. Lastly, if I will input 4 to the function, I will get again 10. Last condition, when the input or x is a number that is at least 5 or greater than or equal to 5, I will use this rule according to the function, which says I have to square the number and then the result I will reduce by 1, or I will subtract 1 from it. Now, what if I input 5? 5 is within the interval x is greater than or equal to 5. So I will have to square 5 and then subtract 1 from the result. So the output that I'll get will be 25 minus 1, which is equal to 24. What if I input 10? This number is a number that is greater than 5. So I will use the rule x squared minus 1. So I will get 100 minus 1, that is 99. And then lastly, if I will input 20, then my output will be 20 squared minus 1, which is 400 minus 1, and that is 399. Alright? This time, we are going to differentiate floor function versus ceiling function. So, we use this symbol for floor function, while this symbol is used for floor or ceiling function. This is floor, this is ceiling. Now, the value of our floor function is always an integer. Now, how do we evaluate a floor or a ceiling function? For floor function, we have to get the number or the integer that is either less or equal to the given value. While ceiling function means we have to write the integer that is greater than the number or equal to it. So it is the nearest integer that is greater than the given value. For example, what is the floor value of 1.25? So if this is our number line, then the floor value of 1.25 will be 1. 0.15 is here. This will go down to 0. While negative 0.4 is between negative 1 and 0. But it's nearer to 0. However, we want the floor value of negative 0.4. That's why we have to move down to negative 1. So the value of the floor of negative 0.4 is negative 1. Then, the floor of 3 is, since 3 is already an integer, then its value, the floor value of this integer, is the number that is equal to it, which is 3. Alright? Now, what is the ceiling value of 1.25? So we have to move up to the number or integer 2. While 0.15 will move up to 1. And then negative 0.4 will move up to 0. And lastly, the ceiling value of the integer 3 is itself. So those are the most important things that you need to know about piecewise functions and floor and ceiling functions. Now let's try to solve more examples. Let's say we're asked to evaluate the following piecewise function at the indicated value of x. So as you can see here, letter A, we're asked to find the value of f of negative 2. And the number negative 2 is within the interval x is less than 4. So what we have to do, or what we will do, is we will evaluate this rule. Doing that, we will obtain negative 7. Next, if we want to find the value of f of 0, what rule are we going to use? Again, this rule, because 0 is less than 4. It's a number that is less than 4. So we will get 0 cubed plus 1, which is 1. Third, what if we want f of 3? Again, we will use the same rule. So 3 cubed plus 1 is equal to 28. Now, this time we want to find the value of f of 4. So, the number 4 is within the interval 4 to 8. The range 4 to 8 because of this indicator. So we will use this rule, the absolute value of the input minus 2. So if we'll input 4, we'll have 4 minus 2, that is 2. And the absolute value of that is 2. So we will do the same in E and F, since both 6 and 7.5 are inside the given interval. Lastly, if we want to find the value of f of 8, we will use this rule, 2x plus 3, because the number 8 is inside the interval x is greater than or equal to 8. So we will get 2 times 8 plus 3 equals 27. So if we want the functional value at 10 and at 12, we will use the same rule, which is 2x plus 3. Our last stop will be here. So let's say our function is given by 2 minus the floor value of x. Let's say our x is 0.25. So what is f of 0.25? So we will replace this x here with 0.25, and the floor value of 0.25 is 0. So 2 minus 0 is 2. Next, what about the ceiling value of the quantity 3x minus 2 at x is equal to 0.6? So we will plug in 0.6 to the function. We will obtain 1.8 minus 2, and that is negative 0.2, negative 1, and 0. So it's here. So the ceiling value of negative 0.2 is 0. Lastly, we want to evaluate this expression at x is equal to 1.2. So we'll replace all the x's with 1.2. 3 times 1.2 is 3.6. If you'll add 5 to it, you'll get 8.6. And the floor value of 8.6 is 8. Here, 1.2 raised to 2 gives 1.44. And the ceiling value of 1.44 is 2. Therefore, we have 8 minus 2, and that is equal to 6.